Hi, good day. This will be a recorded discussion on data analysis and interpretation. Data analysis and interpretation is a lengthy topic. This discussion is only intended to give you an overview on the data analysis and interpretation so that you will have an idea to formulate your chapter 3 or your methodology. Okay, this particular discussion is centered on quantitative and qualitative researches. So part of disclaimer, part of the PowerPoint presentation is retrieved from the PowerPoint materials entitled Data Analysis and Interpretation by Pearson, copyright 2018. If there are any concerns regarding this presentation, you may email it at gjsporque@cpu.edu.ph. This slide shows an excerpt from a finished thesis. This is part of your chapter 3 entitled Data Processing and Statistical Analysis. Okay, the main difference perhaps of this example compared to your proposal is that your proposal will be stated in future tense. For example, it may say the data will be analyzed using statistical package for social sciences version 20. Descriptive statistics, including frequency distribution tables, means, percentages, and standard deviations will be used to summarize the data gathered from the study population. I hope that you can remember that SPSS, or Statistical Package for Social Sciences, is a software for quantitative analysis. Now, this discussion will recap what do you mean by frequency distribution table, what are means, what are standard deviations. Then we'll talk about Pearson's product moment correlation, or Pearson's R, which will be used to determine the relationship between two variables, okay, or your interval or ratio scale specifically. So this will be a recap also of what do you mean by interval or ratio scale. Kramer's V will be used, for example, to determine the relationship between nominal and ordinal variables. So our goal by the end of this discussion is that you will be able to identify the type of variable that you will be encountering for your specific research, and then you will already have an idea of the specific statistical tests that you will be using for the purpose of your research. Now, data analysis plan. This is an excerpt from a qualitative research. So for the data analysis plan, you would detail that analysis of the data will start following the first encounter. This is what usually happens in a phenomenological research. The researcher would read the verbatim transcript approximately 5 times to gain a full understanding of the interview and analyze content embedded within each interview. The researcher is expected to determine the level also of data saturation. As you can see in the next paragraph, the theme and the theme clusters will be derived to uncover the essential textual, structural description and the management of the specific nursing units. A phenomenological data analysis using Kulice strategies will be used. So we'll be having an overview of what are these phenomenological strategies that could be used. And one is your Kulice, which he first formulated way back in 1978. The steps representing the Kulice's process was shown in this research. And then you'll have the details of the specific steps that were being done in the data analysis of a qualitative research based on the description given by the author that you have used. Now let's talk about statistics. We'll first go over quantitative. Statistics is derived from the Latin word which means state. It is a branch of knowledge used to summarize and present numerical data. This enables researchers basically to collect and analyze data. So there are 2 key concepts here in statistics that I want you to remember. So one is parameter and then the other one is statistics. When I say parameter, these are characteristics of population. This data refers to the entire population. When I say statistics, your statistics are numerical characteristic of samples. So for example, if you're doing a research among student nurses and then you gather the data among all 500 student nurses in a certain university, that is a parameter. But if you've taken your sample size, for example, of only 200, okay, and you've gathered the data from the 200, you refer to the data gathered as statistics. The Greek letter mu are used to designate population parameters, whereas English letters such as your S or ST are used to designate sample population or sample statistics. Now, you can see here on the right side of the table that these are the symbols used for sample. So these are the symbols used for mean, these are the symbols used for standard deviation, and this is the symbol for variance. Remember that your variance is standard deviation squared. Now, we have two classification of statistics. Other references could refer to this one as the two branches of statistics. You have descriptive statistics and inferential statistics. Now, let's talk about descriptive statistics. When I say descriptive statistics are aimed towards organizing and summarizing numerical data collected from samples. They allow examination of the study participants. Example would be your characteristics, behavior, experiences. Basically, it wants to organize and summarize information. Okay? Take note of the goal, organize and summarizing information. In other words, descriptive statistics are used to describe your data. Then you have the following examples. Frequency distribution. You will have your frequency distribution table. You also have your measures of central tendency and then the measures of variability. Then we have inferential statistics. Your inferential statistics may be concerned with population, also sample. They use sample data to make an inference about a population. So inferential, you would want to make inferences. You would want to make conclusions from the population. They help determine real differences versus chance differences. Oftentimes, you will encounter here in hypothesis testing that you are testing if there is a significant difference or if there is a significant relationship between two variables. That reminds us that not because something is different when we look at the numbers, statistically the difference is significant. Okay, or because something or there's a certain pattern that can be seen in the relationship between two variables, the relationship is already significant. Okay, for us to say that the relationship is significant, we need to do statistical testing. And then this also determines the likelihood that the sample chosen for the study is representative of the population. So we have your test for parametric and non-parametric samples. So examples of this are your test for differences and test for relationship. Now, for us to understand deeper on statistics, we need to recall the levels of measurement. There are 4 levels of measurement: nominal, ordinal, interval, and ratio. Let's go to nominal. When I say nominal, these are variables that do not have mathematical values. There is no higher or lower value. Example is sex. I cannot say that males are better than females, or vice versa. Next example is religion. I cannot say that Roman Catholics are better or have higher scores compared to Baptists. Okay? Hence, they're just equal. Then we also have civil status. Single, widowed or widower, and then married. I cannot say which one is better. Who's better between the 3? So they're considered to be nominal. On the other hand, when I say ordinal data, as the term implies ordinal, it can be ordered. It can be ranked. Example, honor student. The order of birth in the family. The level of knowledge. Okay, level of knowledge, if I will be classifying knowledge as high, average, and low, is considered to be ordinal. The thing with ordinal is that you will know who is better, you will know who got higher scores, you will know who got higher satisfaction rating. However, you will not know by how much or by how many differences. Okay, you cannot quantify. You only know its first, second, and third. Next, interval and ratio. Interval and ratio are already numerical data, meaning there are scores assigned to the specific individuals, or there are scores assigned to specific variables. Example would be your score in medical surgical nursing. If I will be giving you a 30-item quiz and then you scored 20, somebody scored 25, others scored 26, you know that you are dealing with interval or ratio data. If you will get the blood pressure of your patient and the systolic BP would appear to be 170, 160, 90, you know that you are dealing with numbers, and this could be interval or ratio data. For the purpose of statistics, we need to differentiate what is interval and what is ratio. Okay, when I say interval, there is no true zero and can hold values below 0. Whereas when I say ratio, there is a fixed 0 or there is an absolute 0 that exists. For you to remember that, just remember ratio ends with O. There is an absolute zero. What do you mean by absolute zero? When I say absolute zero, meaning there is nothing that exists when the measurement is zero. Okay, let's have an example. In interval, we have a temperature of degrees Celsius. What do you mean by that? We know that the environment's temperature could be up to 35 degrees Celsius, 36 degrees Celsius. In summer, you can have 40 degrees Celsius. When I say that the temperature of the substance is 0 degrees Celsius, you know that there is still an existing temperature, because we know that 0 degrees Celsius is the freezing point of water. Now, we know that there could also be negative 5 degrees Celsius. There could also be negative 10 degrees Celsius. Okay, that's why it's considered to be interval, because 0 still exists. And below 0, there are still values that you might be interested on. When I say ratio, the 0 point is fixed. Pick for as an example, age. We know that age could be 12 years old, could be 18 years old, could be 20, 25, 60 years old. But if I talk age of 0, we know that there's no such thing as age 0. Okay? The same with height. There's no such thing as height of 0. Meaning there's no substance, or there's no matter, there's no human that exists that the height is 0. Okay? Meaning the 0 there is absolute. Okay? That's why it's referred to as ratio data. Now we are looking at this example of the study entitled Factors that Influence Family Planning Practices Among Married Couples in a Certain Barangay in Iloilo City During the COVID-19 Pandemic. This is a proposal in progress, so let's try to determine the types of variables or the levels of measurement of the variables that is in the example that they have. Now, for you to specifically determine the variables, it would be wise for you to have a table. We commonly refer to that one as the table of specifications. The table of specifications would ensure that your statistical test is aligned to your objectives. Okay? There are various components for your table of specifications, but for the purpose of this discussion, let's only focus on the variable. Okay? Your variable, specifically your independent variables, and then your dependent variable. And then we'll try to determine the level of measurement of these variables for us to apply what we have learned in the levels of measurement to your actual study. Okay, now let's look at the diagram or the paradigm of the research variables shown above. If you can see, the first variable that they have is employment status. When I say employment status, it could be employed, it could be unemployed. You could also say that somebody is on part-time basis, whereas somebody is on full employment. Okay, so for employment status, what do you think will be the level of measurement? Will it be nominal, will it be ordinal, or will it be interval or ratio? Okay, for this one, you may consider your employment status to be nominal. That is, if you would want to classify your employment status to several categories, such as, for example, you will say unemployed, employed, self-employed, part-time, consultant. Okay, if you have those categories, you can say it's nominal, because you cannot say that a part-timer is better compared to those who have no job, or you could also not say that a full-time job is better compared to those who do not have jobs. Whereas, if you will classify it as employed or unemployed, you may consider your employment status to be ordinal. Next, you have monthly family income. Now we're talking about numbers. And when I say numbers, you know that numbers are either interval or ratio. However, for the purpose of statistical analysis and tabular presentation, okay, you might want to classify your monthly income. If you would want to classify your monthly income, let's say for example, you will be classifying it as high income, average income, and then you have low income. You are making your income to be a ordinal variable. Okay, if you would want it to be classified that way, that makes it to be an ordinal variable. Okay, however, if you would want to analyze income as a number, you know that money, there is no such thing as zero money, meaning there's no money that exists there. You know that money is on the ratio scale. Take note that it is possible for you to step down the level of measurement. What do I mean by that? Your interval and ratio scale could be possibly converted to ordinal scale. Your ordinal scale could be possibly converted to nominal scale. However, it is not possible for you to convert nominal scale going towards ordinal scale. Also not possible to convert ordinal to interval or ratio. But again, it's possible to convert interval ratio to become ordinal data. So in this case, we are converting your data and making it ordinal. Then we have accessibility of family planning resources. For the accessibility of family planning resources, you might need to consider your definition of terms for the accessibility of family planning services. Okay, for example, if you would want it to be in a Likert scale, then you know that you can convert the data to ordinal. Okay, what do I mean by Likert scale? Let's have some rough examples of a questionnaire. If I will have a questionnaire, for example, answerable in a Likert scale of 5, then since we're talking about accessibility, let's say for example your question will be the rural health unit, okay, is within easy reach from our residents. Okay, that could be the question. And then you might have the Likert scale, which would say strongly agree. Then you have agree, then neutral, then you would have disagree, and then you would have strongly disagree. If this will be the case, for example, for your accessibility, you know that you can get scores from this one. Okay, you can get scores from this questionnaire. Let's say, for example, you have 5 questions for this one. And then you have a tendency to assign numbers. Okay, so strongly agree might be 5, 4, and then 3, 2, 1. If this will be your classification of categories for this one, if you will be measuring accessibility in terms of this one, okay, so what will happen is that you convert your accessibility to a numerical value. Okay, maybe you can refer to that already as the level of accessibility. And looking at this, you know that there will be 5 items or 5 points. There could be a maximum of 5 points per question. Okay, and this specific example. In other examples, you can have 7. So there could be 5 points per question. And you have 5 questions. Meaning the maximum score that the respondent could get is 25. The minimum score that the respondent could get is 5. And now, if you want to make categories, you need to determine the difference between the maximum and the minimum score. That will be 25 minus 5, and that will give you 20. If you have decided to have 2 categories or 3 categories, for example, so what you will do is divide 20 by 3. That will give you roughly at around 8.6. If my mathematics serves me well. Okay, let us see. 20 divided by 3. Okay, I'm sorry, it's 6.67. That will give you 6.7. So that would mean that there will be around 7 of differences. The difference between the intervals is 7. So let's have an actual example. If you will be making categories for your accessibility, okay, let's have accessibility there as an example. Okay, your categories may be named as readily accessible, moderately accessible, let's have it as accessible, and then rarely accessible. So how would you know if it is readily accessible? Let's start with rarely accessible. We know that the lowest score is 5, so it could be 5 to 11. Okay, it's 11 since you know that the difference between the variables should be 7. Okay, now you can have here 12 to 18. Okay, in such a way that, you know, in between 11 and 18, there will be a difference of 7. And then you will have 19 to 25. Okay, this will be your categories for accessibility. Again, as a researcher, you have an option, depending on your objectives, to make accessibility as an interval ratio data, or if you would want to have categories, that becomes ordinal data. Okay, so in this case, for this example, I'll be using ordinal data for the accessibility of resources. And then you have the next here, availability of family planning methods. So depending on how you will be scoring them, on your criteria or on your objectives and definition of term, you may consider it as interval ratio or ordinal. Now for dependent, we have family planning practices. Okay, so for the family planning practices. Now, this is yet dependent as to how the group will measure family planning practices. If they will say practicing, not practicing, you can consider it as an ordinal data. However, if they will say frequently practice, occasionally practice, rarely practice, that might be considered to be an ordinal data or interval ratio data. So it would go back to how you define your terms. If you can notice, you cannot also identify the level of measurement if you do not have a blueprint on how you will be working on your questionnaire. So you need to have a glimpse or you need to have an idea on how you define your questionnaire. Okay, if your questionnaire can be converted to scores, there is a possibility that it can be measured in interval or ratio scale. If you plan to make categories, that will be measured in ordinal scale. So this is an example of how you will be applying, okay, the principles of level of measurement on your actual research. Okay, for family planning practices, I'll place this first in ordinal scale, just for the purpose of example. Then later on, we will add a column here which will talk about your statistical test. Now let's talk about descriptive statistics. This is an example of a frequency distribution table. As you can see, it is referred to as frequency distribution table because shown on this table is the frequency. When I say frequency, it is the number of counts specific to a certain variable. So meaning, in this case, there are 24. Among the 100 respondents, for example, there are 24 which were aged 4 to 6 years old. About 30% are aged 7 to 12 years old, and then about 40% or 37.5% are adolescents. So as you can see, this is a frequency distribution table. It makes use of your frequency, it makes use of your percentages. Depending also on the type of the variable, you can have the mean and the standard deviation. As you can see, it will be variables which are expressible on ratio scale, wherein we can compute the mean and the standard deviation. So in this case, I know that the mean age of the children with epilepsy is 9.89, specifically about 10 years, and the standard deviation is 4.2. If you can notice, in case of sex, we do not have the mean and the standard deviation because we cannot compute for the mean and standard deviation of information or data in the in the nominal or ordinal scale. Again, we cannot compute for the mean of data on the nominal and ordinal scale. So this is your frequency distribution table. Notice where the title is situated. Also notice the format that is being used. Now, the measures of central tendency. There are three most common measures of central tendency. You have your mean, you have your median, and then your mode. When I talk about mean, it is the arithmetic average. Average, that's the mean. It is the most stable measure, but it is affected by extreme values. What do I mean by extreme values? Let's say, for example, you're taking the examinations in MS. Try to take down notes of these scores. Among a group of 5 students, the scores were 72, 73, 74. Somebody got 90, and then somebody got 60. If you would look at this, 90 and 60 are considered to be extreme values. All of these values will be used in computation of your mean, which means that the value of 60 and the value of 90 could also possibly affect your mean, because all of these values will be used in the computation of your average. Median. Median is a value that splits the data into two halves. It is influenced by position of items, but not their values. Okay, again, this is influenced by the position of the items. If you have a data set, before you compute for the median, you need to arrange the data set in an array. When I say data array, the data are arranged from either lowest to highest or highest to lowest. Okay, then you have the mode. The mode is specifically the most frequent data in the data set. Okay, it is the data with the highest frequency. Your mode is not affected by extreme values, and your mode is also useful if you're talking about qualitative data. So let's try to compute for the mean, median, and mode. For this example, let us consider your scores in an MS quiz. Okay, let's say for example, it's a 30-item quiz and the scores of the students are as follows. You have a score of 20, somebody got 19, 18, let's say 16, somebody got 25, somebody studied well to get 29, and somebody got 30. So these are the scores of, let's say, 7. Let's make it 8 students. Somebody got 30. They studied together. Now, let's have your mean. When I say mean, mean basically is the average of this information or of this data. So you can simply use, okay, you can simply use average if you're using your MS Excel. Okay, you can compute for the average. Or if you're using your calculators, what do you do is to add them up first and then divide them by 8. For example, you would want the sum of this one, okay, and then divide by 8. Still give you an answer of 23.375. So this will be your mean. Now, median. When I say median, as I have mentioned, you need to arrange the data from lowest to highest. So if I want to compute for the median of this one, I will be arranging the data from highest to lowest. If you're using Microsoft Excel, you can just simply sort the data, home, sort, small to high. Okay, and then this is the data arranged. Now, there are two things that you need to remember for median. The first one is it should be arranged from lowest to highest, highest to lowest. The second one is for you to find out if the number of information or data available is odd or even. So for this one, since this is even, okay, so 16, 18, 19, 20, the middle data or the middle number that we would choose is between 20 and 25. If that's the case, we need to add 20 and 25 and then divide it by 2. Okay, we need to add 20 and 25 divided by 2. Hence, the median for this data set is 22.5. Again, the median is 22.5. However, if I'm talking about a data set with an odd number of data or information, let's say for example, this example on the right that I've just made, okay, if this is the data set that you have, okay, you will just be counting for the middle. Okay, what's the middle data available? And in that case, since we have 9, we know that 9 divided by 2 is 4.5. So it would come after 4.5. It's the 5th data. Hence, your median for this example is 20. Because when we say median, median is the middle. Okay, it's the middle data in the data set. Okay, try to remember it like that. So again, if there are odd numbers here, this is 9. So it's just the middle value. If there is even, like this one, you need to divide the two values in the middle and then divide it by 2. That's how you compute for the median. Then let's talk about the mode. When I say mode, your mode is the most frequently occurring data, okay, or the most frequently occurring score. In this case, the most frequently occurring score is 30. So you will say that this mode is 30. Okay? Now, another example. It is also possible that there will be 2 modes. For example, in this new data set that I have created, the mode will already be 16 and 30. Okay? The example on the left is referred to as unimodal, whereas the example on the right is referred to as bimodal because there are 2 modes. Okay? There will be data sets which are polymodal, which means there are more than 2, okay, 3 or more modes available in the data set. So that's how you compute for your mode. Other measures of central tendency other than the mean, median, and the mode are your quintiles. Your quintiles are also known, there are 3 types of quintiles. One is your quartile, the other one is your decile, and then the other one is your percentile. Quartiles divide the data set into 4 equal parts. That's why it's referred to as quartile. Your decile divides the data set into 10 equal parts. Your percentile divides the data set into 100 equal parts. Okay, so those are the purpose of your quartile, decile, and percentile. With that, you know that the second quartile, the 5th decile, and then the 50th percentile are all equal to the median because these are all middle values. Okay, when do we apply these quintiles? A good example will be your NAT scores or your nursing aptitude test scores. If you can notice, your nursing aptitude scores can be converted to percentile. You can have your percentile rank for your you can have your percentile rank for your NAT scores. So if your percentile rank is 80, that would simply mean that you performed better compared to the 80% of those who took the examination. However, your score is lower compared to the 20% who took the examination. Okay, so if this is 80, that's your score, let's say 80, meaning you performed lower to the upper 20%, and then you performed better to the lower 80%. That's how you interpret your percentile scores. So if you have a friend or classmate or you got a score of 99 plus plus in the percentile rank for your NAT scores, that would mean that you scored better, you performed better compared to the 99% of the participants or 99% of those who took the examination. Okay, that's what we meant by your percentile scores. Let us try to compute for the values of the mean, median, and mode for the following data set. You may pause the presentation while you are computing. Let's have the answers. So for the first example, the mean will be 14.4. How did we come up with that? 18 plus 10 plus 12 plus 12 plus 20 divided by 5. That will give you an answer of 14.4. The median, if you will be arranging the data set, okay, it will give you a data array of 10, 12, 12, 18, and 20. That places the median at 12. The mode for this one, the most frequently occurring data is 12. Hence, the mode is also 12. On the second example, the mean is 35.75. The median, it's an even number, so 30 plus 35 divided by 2 would give you a value of 36.5. Then the mode, there is no mode for this one. Since the information there is no more frequently occurring data. All of them only occurred once. For those who are interested, you are also informed that the mean, median, and mode could also be computed using your MS Excel. For the mean, you can use your average as the formula. For the median, you simply type median, and then you highlight the data set there. That will give you the value of the median. And then for the mode, you simply type mode, and it will give you the value of the mode. Okay, so you can just copy paste the formula, and then it will compute for the mean, median, and mode for your data set. So this one is a comparison of the mean, median, and mode of section H and section I. From that, you can see that the scores of section H is higher compared to section I in reference to the mean, which is 23.375 versus 22.5. After the measures of central tendency, these are the measures of variability. There are three measures indicated on the slide. First is your range, then your variance, and your standard deviation. Take note that the measures of variability will measure how dispersed or how scattered the data is in a scatter plot. So the purpose of your measures of variability is to determine the differences or how different is one data from another. In other words, it measures how homogeneous or heterogeneous the data is. Now, looking at the example below, you have Group A and Group B, which has the standard deviation of 10.2 and 15.7. From this data or from this information, we can conclude that Group B is more heterogeneous compared to Group A because the standard deviation of Group B is higher than that of Group A. As you can see on the table, the standard deviation of Group B is 15.7, and then the standard deviation of Group A is 10.10. In other words, Group B again is more different to one another compared to that of Group A. For a more specific example, we will have that on the next slide. This slide shows how to compute for the standard deviation using Microsoft Excel. So for you to compute standard deviation, you simply need to use the formula standard stdev.s. That means standard deviation for a sample size, and then highlight the data that you have. Okay, so you can see that for section H, for example, the standard deviation is 5.8, whereas for section I, the standard deviation is 6.9. Okay, so what can we interpret from this one? Again, as I have mentioned, standard deviation is a measure of heterogeneity, meaning how different one data is from one another. From this, we can conclude that section I is more heterogeneous to section compared to section H. Because the standard deviation of section I is 6.91 compared to the standard deviation of section H, which is 5.8. Now, to expound further, if you would look at the scores of section H, their scores are 16, 18, 20, 29, 30. They're closer to one another compared to the scores of 13, 15, and then 30. Okay, that means that the scores of section I are more of being extremes compared to closer to one another. Okay, let's try to change the data set. For example, if I will change the scores to lower ones, 9, 10, 12, and then somebody got 30, 28. Okay, the standard deviation tends to be higher. This indicates that the scores are far from one another. If we will place this on a scatter plot, okay, a scatter plot would demonstrate how data are scattered from one another. So let's label section 8 as group, section H I mean as group 1. And then let's label section I as group 2. If you will have them on a scatter plot, from here you will see how they are scattered from one another. Okay, the data here shows the data of section H. As you can see, the dots are closer to one another. And then the data here shows section I. The dots are far from one another, meaning the standard deviation is very high. Just to define the three measures of variability, your range is simply the difference between the maximum and the minimum value. On the other hand, your variance is the square of your standard deviation. So in other words, standard deviation times standard deviation. And then your standard deviation is the square root of your variance. Again, for the measures of variability, the higher the value, the more dispersed, the more spread, and the more heterogeneous the data will be. Now let's go to inferential statistics. For this discussion, we'll be focusing on the measures of differences and the measures of. Let's talk about the test for differences. So there are three tests for differences. One is the t-test, another is z-test, and ANOVA. Let's talk about the main differences between these tests first. So t-test is used if the sample size is less than 30. C-test is used if the sample size is greater than 30. T-test and z-test are used if you are comparing two groups. On the other hand, ANOVA is used if you are comparing more than two groups. So again, if I want to compare the scores of section A and section B in medical surgical nursing, I will be using z-test because there are more than 20 or there are more than 30 respondents from the sections. If I want to compare the scores of section A, B, C, and D, for example, in their examination in maternal and child nursing, I will be using analysis of variance because I am comparing more than two groups. Okay, when you are comparing three groups or more, you will be using ANOVA or analysis of variance. Your analysis of variance is also known as your F-test. It is also known as the F-test. Now let's talk about the three types of t-test. There are three kinds of t-test. T-test, I mean, you have independent sample t-test, you have paired sample t-test, and then you have t-test for proportions. Independent sample t-tests are used if you want to compare two groups. For example, I want to compare the performance of section A and section B in a certain examination. That will be independent sample t-test. When I say paired sample t-test, you want to compare the performance of the same group of respondents before and after a specific intervention. Let's say, for example, I would want to compare your pre-test and post-test scores. When I will be doing the pre-test, I will have all the section A respondents. When I'll be doing the post-test, I will be doing it on the same respondents, still section A. That is what you refer to as your paired sample t-test. Basically, you pair two data. You pair the pre-test and the post-test scores, and then we compare for differences. And then we also have the t-test for proportions. The t-test for proportions, as the term implies, is used to compare two proportions or also to compare a sample from a population data. Let's go to the test for relationships. So for the test for relationship, you need to identify the level of measurement of the data that you will be using. So as you can see on the table on the slides, there are a lot of tests for relationships which can be found on the third column. So if the independent data, for example, is nominal, And then the dependent data is also nominal. You can use Kramer's V, chi-square, or phi. If the independent is nominal and then the dependent is ordinal, you can use chi-square, Yule's Q, or theta. If the independent is nominal and the dependent is either interval or ratio, we'll be using eta. And then the list go along. Okay, if you have ordinal and ordinal, we use gamma. If you have interval ratio for independent and then interval ratio also for dependent, you can use your Pearson's R or your Pearson's product moment correlation. This slide illustrates the data processing and statistical analysis under methodology. If you want to go through the example, you may pause the presentation. This is an example of how the data will be interpreted or how the values for the relationship will be interpreted. There are different ways of interpreting the values depending on the test statistics and depending also on the references. As you can see, this interpretation is applicable for gamma and also for Pearson's R. But that would depend again on the reference or the specific book in statistics that you will be using. So this means that if the value of gamma or Pearson's R would be 0.80, for example, it indicates very high correlation. If the value is playing between 0.41 and 0.70, that means that there is substantial correlation. So again, you need a statistics book as a reference for this one. This one is an example of analysis of data in an experimental study. So it says that all data will be analyzed using analysis of variance for CRD. CRD is completely randomized design, which is commonly used in experimental studies. The significant differences among the means will be tested using Duncan's multiple range test. So your Duncan's multiple range test is an example of a post hoc test or a post ANOVA test. Because your ANOVA will determine that there is a significant difference between the groups, but it will be your Duncan multiple range test which will be able to identify if what group is different from one another. Just as an example of the discussion that we have on the test for relationships, okay, getting this example on the study on the family planning, if the employment status is considered nominal and then the dependent variable, the family planning practices, is considered ordinal, the statistical test that will be used is nominal, ordinal. We'll be using your chi-square. One particular test that we can use is chi-square based on the table that we had on the slide. Then, for monthly family income, because family income was considered ordinal, and then family planning practice is also ordinal, one statistical test that we can use is your gamma. Then, for the accessibility of family planning resources, ordinal, you can also use gamma. And then availability, ordinal, you can also use gamma. Okay, that is if this will be the categories of your variables depending also on your questionnaire and then the objectives that you will be using or the objectives that you had for your research. Let's try other examples. Now, if I will go in the study entitled Preparedness for COVID-19 Response Among Frontliners in a Private Secondary Hospital in Iloilo City, we have the following variables. With these variables, let's try if what will be our statistical test. Okay, let's try profession. Profession. When they say profession, this group could mean that the profession is either a nurse, either a physician, or a medical technologist. If that's the case, what do you think will be the level of measurement? This one will be considered to be a nominal data. Now, let's pick a dependent variable. According to this group, the dependent variable is the level of preparedness for COVID-19 response. Now, by the way that their diagram is presented, it seems that there are a lot of factors or there are a lot of subcomponents under the level of preparedness. So that will be depending on the group on how they will define leadership and coordination. So let's say, for example, that the dependent variable is level of preparedness for COVID-19 response. Okay? The group may opt to make it interval ratio or to make it ordinal. For the purpose of analysis and table presentation, it is usually used in the ordinal scale. Okay, so in this case, we have nominal and ordinal. We can use chi-square. Okay, we can use chi-square. Then, let's have one example again. Place of, okay, let's have tenure. Okay, for tenure. Tenure could be employed or unemployed, or it could be tenure could be they could be referring to the number of years. Let's say that they're referring to the number of years. When they're referring to the number of years may be classified 0 to 6 months, 6 months to 12 months, and then 1 year to 2 years, and so on. If that will be the case, we can have it on the ordinal scale. If this is on the ordinal scale and then the level of preparedness is still in ordinal scale, we can say that we can use gamma. Okay, we can use gamma because gamma could be used if both the independent and dependent variable are said to be in the ordinal scale. Okay, so that's one example. Let's go to the example, nurse's workload. For the nurse's workload, okay, let's pick our table so that we can have a guide later on. Okay, going to the study about the nurse's workload. If we're talking about the nurse's workload in terms of sex, we know that sex, whether male or female, is considered to be nominal. And our dependent variable, so we have the dependent variable level of workload. Since it is level, the tendency is that this data is measurable. So that could be in the interval or ratio scale. Again, the group might want to categorize it to two variables or three categories, I mean. With this, you can say that you can use your nominal ordinal. For nominal and ordinal, you can use your chi-square. Okay? How about if the group decided that the level of workload will be in interval or ratio? Yes, they can do that. Okay, let's say for example, age. If the group will consider age to be interval ratio, and then we'd also consider the level of workload in terms of interval or ratio, okay, interval or ratio scale, we have two interval ratio scales here. If you can recall this presentation here, okay, this would remind us that if both the independent and dependent variable are on the interval ratio scale, we can use your Pearson's R. Again, your Pearson's R could be used. Okay? Now, you might be asking, so what is level of workload? Will it be interval ratio or ordinal? That would depend on the objectives of your study, your operational definition of terms, and then maybe the literature that you can find through the web. Okay? I hope that these specific examples could help. Now, let's have your health literacy and then public trust and vaccine perception. Okay? This would depend as to how the group would define public trust. Okay? Let's say for example, if I talk about public trust and then they will say that the public does not trust or do not trust, they can say that it's in the nominal scale. However, if they will say that public trust will be in levels, okay, for example, they will say there is high trust, there is average trust, and then there is low trust to the government, then they can say that this one is in the ordinal scale. So that would depend as to how they will structure their questionnaire. Now, dependent variable. Okay, dependent is COVID-19 vaccine acceptance. So when I talk about COVID-19 vaccine acceptance, the group might want to formulate an acceptance questionnaire. An acceptance questionnaire may be in the form of Likert scale, which can be used or which can be scored from a scale of 0 to whatever 50. Now, if the score will be used, it could be interval or ratio scale. Okay? Whereas, if you would want to categorize it, okay, to highly acceptable, averagely acceptable, or moderately acceptable, and not acceptable, this might be placed in the ordinal scale. So if both ordinal scale, you can use your gamma. Whereas, if you will be using your interval ratio scale here, if you can use your interval ratio scale here, so you have nominal and then you have your interval ratio scale, then you use eta. Okay, you'll use your eta. Okay, so these are examples. These are examples of how you will place your public trust and ordinal. Okay, so it depends on how you will be measuring your variable, how you will be measuring your questionnaire, okay, and all those data. Okay, so it depends again on your objectives, it depends on how you define your variables, and it depends how you make your questionnaire. Okay, then for the live experiences of elderly and nursing home, amidst COVID-19 pandemic, obviously there are no independent and dependent variable here because this is a qualitative research. Okay, we can have this as an example later on the qualitative study that we will be working, or qualitative analysis that we. Now let's talk about qualitative data analysis. Again, this is an overview of doing your qualitative data analysis. Now, when I talk about qualitative analysis, there are several types of qualitative analysis. Qualitative analysis could be interpretive, it could be descriptive, it could also be narrative, it could also be thematic. Let's talk about descriptive analysis. Descriptive analysis. This is best to frame the exploration of individual experiences. Now, in your descriptive analysis, bracketing is usually applied. This is the main difference between descriptive analysis and interpretive analysis. In interpretive analysis, bracketing is not usually applied. Okay, so we're discussing descriptive analysis first because usually descriptive analysis or descriptive phenomenological studies are the first inclination of beginning nurse researchers. Now, the basis of your descriptive analysis is the Husserlian philosophical frame. So if you will be asked in the theoretical or the philosophical basis of your phenomenological research, that will be more of Husserl. Okay, according to the Husserlian philosophy, okay, we need to focus on what do we know as persons. It has four basic steps: bracketing, intuiting, analyzing, and describing. So when I say bracketing, bracketing is the process of identifying and holding abeyance, preconceived belief and opinions about the phenomenon. When I say bracketing, basically your preconceived belief and opinions are removed from the analysis, okay, or removed from your understanding of the phenomenon. Okay, according to Husserl and colleagues, researchers have strived to bracket out prepositions and inform the data or confront the data in its pure form. So usually they would have your reflexive journal. The purpose of the reflexive journal is for the researcher to indicate his own or personal opinion about the phenomenon under study. So the purpose of this is for the researcher to realize if there are personal contributions or personal point of views that are being inserted in the analysis of qualitative research. Then we have intuiting. When I say intuiting, they should be open to meanings attributed to the phenomenon by those who have experienced it. In other words, they should intuit, okay? They should listen to what the respondents and participants are saying about their own experiences. Analyze. They should be able to extract significant statements, categorize, and make sense of essential meanings. Okay, they need to be able to extract significant statements again, to categorize this statement and make sense of its essential meaning. Whereas when I say describing, researchers come to understand and define the phenomenon. Okay, so basically the first step that you need to do is to bracket. Then, intuiting, you listen, you need to be open to the interpretation of those who have experienced it. Analyzing, when I say analyzing, you should be able to extract the themes. And describing, you should be able to describe the themes. Now, in your descriptive analysis, you could have several sources. If you can recall the example that I have shown on the earlier slides, okay, we have mentioned Kulaisi in 1978. There are two schools of analysis for descriptive analysis. You have your Duquesne School of Analysis, then you have your Utrecht School. Okay, so these two has different or various point of views on how to analyze a phenomenological research. Now, Kulaisi, 1978, Georgi, 1985, Van Kam in 1966. So if you would want to look deeper into how you will be analyzing your phenomenological research, you might want to open up the writings of these authors. For example, Kulaisi has detailed 7 to 8 steps of his procedure in analysis. These steps can be shown on the right side of your slides. So as you can see, these are the steps that you will be following if ever you will employ Kulaisi's methodology. Okay, whereas you also have the option to use Georgie's, you also have the option to use Van Kam's. Okay, you need to read because these are specific procedures that needs to be followed. Van Manen. Van Manen had combined the characteristics of both the descriptive and interpretive phenomenology. Okay, Van Manen of the Utrecht School has combined the characteristics of descriptive and interpretive phenomenology. Hence, some authors would argue that Van Manen's methodology could be used in both descriptive and interpretive types of research. Now let's talk about interpretive analysis. In interpretive analysis, interpreting and understanding is the main focus. They say they want to interpret, they want to understand, and not just to describe. Okay, as mentioned, bracketing is not usually included in this type of analysis. This is based on Heideggerian philosophical framework. Okay, for your descriptive, you have Husserlian. For your interpretive, you have your Heideggerian. So you have your Heideggerian hermeneutics. Heidegger was actually a student of Husserl. However, according to Heidegger, he believes that it is not possible for persons to bracket. It is impossible, according to him, to separate one's own point of view to that of the world's. So, for him, bracketing is not possible. That's why he separated and then he had his own Heideggerian philosophical frame. According to him, hermeneutics is the basic characteristic of human experience. It is considered to be the basic characteristic of human experience. And when I say hermeneutics, this is the art and philosophy of interpreting the meaning. Interpreting, I mean, the meaning of an object, regardless if that is a text or a work of art. So if you will be having interpretive analysis, there are some interpretive researchers who would employ, for example, the use of pictures to understand the lived experiences of the patients or the respondents. Some of them would use objects to understand further the meaning of the things that your patient are sharing. Okay, this is what you call interpretive analysis. So the goal is to enter another's world and discover the understanding found there. Unlike in your descriptive, you just want to be observing or you just want to observe based on their experiences shared. Whereas in interpretive, you really want to be immersed on the world where your respondent is. Now, they have this concept referred to as hermeneutic circle. A hermeneutic circle indicates that one understands the whole of a text. Okay? By text, we mean the transcript of the interview in terms of its parts and parts in terms of the whole. Okay, they refer to that one as hermeneutic circle. Now, Heideggerian hermeneutics, there are two common authors that are being used for this procedure. One is Gadamer and the other one is Benner. So Gadamer's writing emerged in 1975. Benner's procedure emerged in 1994. Now, narrative analysis. Analysis is another kind of qualitative analysis. In this type of analysis, life stories research is a narrative theory approach whereby individuals, stories, and storylines are understood. For such research, data can be collected in a variety of ways, such as interview, focus group session, blog entries, and open-ended program evaluation. This approach can be paired with various other data analysis techniques. So basically, what you are looking into is the story and storylines of your respondents. Okay, this is your narrative analysis. On the other hand, we also have thematic analysis. Thematic analysis may actually be part of your descriptive and your interpretive analysis. But in your thematic analysis, there is no specific procedure followed. Okay? This is usually applied to a set of texts such as interview transcripts. The researchers closely examine the data to identify common themes, topics, ideas, and patterns of meaning that come up repeatedly. So basically, they are just looking if what are the themes that would emerge. Okay, it's an interview, then thematic formation or analysis, and then describing the phenomenon, okay, or the themes. They are not following rigid procedures such as York, Colaisi, Van Manen, and other things mentioned in descriptive and interpretive phenomenology. Then, we have the term qualitative data analysis software or your QDAS. Your QDAS, just like your Atlas TI, is a software that can store data, edit data, retrieve segments of text, and assemble data according to themes or categories. Data interpretation. So take note that the data interpretation in your qualitative analysis frequently occurs simultaneously with data collection. For example, if you're doing your Colaisi's interpretation, Colaisi would advocate that while you are doing the interview, you're already starting to take down notes on what are the things observed from your patient. After the first interview, you need to interpret the transcript. And then as you go along, formulate themes and then wait for the themes to saturate. Then during the interpretation, the researchers would pore over their data again and again, trying to find meaning in the data. Okay, you do not read the transcript once or twice. You need to reread and reread the transcript until you will be able to formulate your own respective themes. And perhaps there are relationships between the themes and patterns that mean something. So this is an example. This is an example of how a theme is being described. Okay, this is an excerpt from a study entitled Transitioning Experiences of Middle-Level Nurse Managers, which was conducted by Professor Gustillo in 2018. Okay, in this example, you can see that the major theme are the presence of trials. So you will be defining what you mean by trials. And then for theme 1, okay, the theme 1 is presence of work pressures. And then for the presence of work pressures, you would have, for example, a description there. And then since we have sub-themes, if you would look at here, the sub-themes is having a lot of responsibilities. And then you have verbatim, okay, verbatim statements from the respective respondents. If you can notice, there are names here, Alex, Ellen, okay? These names are just pseudonyms. These are not the names of the actual respondents. Other than that, there are several statements that were used in order to come up with this sub-theme and this theme. However, only few are being used here as an example for your chapter 4. The detailed description of these themes and the detailed statements should be accessible in case needed. Here are the references used for this lecture. Thank you very much for your kind attention. Along the lecture, if I have mentioned patients, I might have been referring to respondents or participants during the research study. Thank you very much for your kind attention.